Yeah, welcome once again into this discussion. We are going to discuss about the mechanism of contraction of the skeletal muscle. My name is Dr. Solomon Oguta. Basically, we have three types of muscles within the body. That is the skeletal muscle, smooth muscle, and the cardiac muscle. The smooth muscle is involuntary, non-striated, while the cardiac muscle is also involuntary but striated. For the case of skeletal muscle, the skeletal muscle is under the voluntary control of your body. It is striated, and its location, it forms up the body covering. It is located on the external part of the body and forms up the body wall. Now, because it is voluntary means that you have control over the skeletal muscle. Its contraction starts by the coming of impulse. This impulse is generated from the central nervous system, notably the brain. So the brain generates a motor impulse and transmits that impulse to a specific group of muscles via a motor neuron. For its contraction, really, we are going to start our discussion at the point of the neuromuscular junction. Now, when we have the arrival of an impulse at the neuromuscular junction, arrival of impulse at the neuromuscular junction, there are changes that are going to take place at this junction that will allow the nerve to be transmitted from the neuronal side to the muscle side. By the way, neuromuscular junction is a special type of synapse. It is the junction between the nerve and then the muscle. Because the impulse has been taken to the neuromuscular junction, there's going to be changes. First of all, there's going to be opening of voltage-gated sodium-ion channel to allow the influx of sodium to the presynaptic neuron. That influx of sodium is going to cause docking of the neurotransmitter filled vesicle filled with acetylcholine to the neuronal membrane, which will allow the release of neurotransmitter to the synaptic cleft by the process of exocytosis. Once the acetylcholine has been released at the synaptic cleft, the acetylcholine will diffuse and look for its receptor, which is located on the muscular side. Attachment of the acetylcholine to the receptor is going to cause the conformational change on the sarcolemma that will end up opening the ligand-gated sodium-ion channel. Influx of sodium-ion channel is going to cause local depolarization. Okay? Now, this local depolarization is what is called end plate potential. This is called end plate potential. This end plate potential is going to develop a nerve and cause action potential. It's going to cause action potential. This is already the nerve impulse that has already crossed from the neuronal side to the muscular side. Now, this impulse will be conducted to the interior of the muscle cell. Okay? Will be conducted to the interior of the muscle cell. Within the interior of the muscle cell, we need calcium for the process of muscle contraction. So it is going to cause the release of calcium from the intracellular stores, that is from the sarcoplasmic reticulum. Here, calcium release. Calcium will be released. Calcium release from sarcoplasmic reticulum, because sarcoplasmic reticulum is the only calcium storage area within the muscle cell. Once calcium has been released, the next step here is going to be binding of calcium to its binding site, which is present on troponin C. Troponin C is the binding site of calcium, and it is located on the F-actin filament. Okay? Now, once calcium is bound to troponin C, it's going to cause the conformational change on the overall structure of the F-actin. That will end up dislodging the tropomyosin from the binding site of the head of calcium. Here is going to be dislodging or removal of tropomyosin. Removal of tropomyosin from myosin binding site. At the same time, when the tropomyosin dislodging is taking place, the troponin I is also being inhibited. Remember, the troponin I, when the muscle was in a relaxed state, it was inhibiting the ATPase activity on the head of myosin. Now, once the troponin I is inhibited, there's going to indirectly activate the ATPase activity. Okay? At the same time, there is activation of ATPase activity. Activation of ATPase activity. At this point, the binding site of the head of myosin will be free, and the myosin will bind to its binding site on the F-actin, and the ATPase activity is going to hydrolyze ATP into ADP plus inorganic phosphate and release enough energy for the process of muscle contraction. Okay? So, we'll follow with the binding of myosin to its binding site. And the release of energy, because ATPase activity has already been activated and is going to hydrolyze adenosine triphosphate to supply enough energy. At this point, the head of myosin will move back and forth on the F-actin filament. This is what is called slide filament theory of muscle contraction. Now, to end up this slide filament theory, we have to look at what is going to take place within the sarcomere. Within the sarcomere, as the myosin is moving back and forth, pulling F-actin together, you will find that the sarcomere will shorten. The H zone within the sarcomere disappears. The I band reduces. I band decreases or shortens. The A band, which is the dark band, will remain the same, will remain unchanged. Okay? And the two Z discs will come closer to each other. That will mark up the point where the muscle is contracting. Muscle must not contract forever. There must be the stimulus that should cause muscle to relax. This starts from a point whereby the acetylcholine is being removed from its binding site at the neuromuscular junction by the action of the enzyme acetylcholinesterase. So acetylcholinesterase degrades the acetylcholine from its binding site, okay, to make that binding site free. At that instance, the flow of impulse to the interior of the muscle cell is going to be stopped. The concentration of calcium that was high in the interior of the muscle, that is in the sarcoplasm, is going to be reuptaken back to the sarcoplasmic reticulum. Now, once the calcium has been removed and taken back to sarcoplasmic reticulum, the tropomyosin will come and close the binding site of myosin on the head of actin. And the inhibition that was previously put on the troponin I will be removed. So in this case, the troponin I will inhibit the ATPase activity. That is basically how the skeletal muscle contraction takes place. Remember all the steps that we have described here. It starts from arrival of impulse at neuromuscular junction, impulse taken to the interior of the cell, release of calcium, and then calcium binding to its binding site, and then dislodging the tropomyosin from its binding site, inhibiting troponin I, and causing the head of myosin to attach to its binding site, and energy will be provided. Okay? So generally, thank you for watching. Get us in the next update. Thank you.